Bismillahirrahmanirrahim. Hello students, this is Hamza Noor from Aero Education Network, and today I'm going to solve some questions from past papers International A-Level Edexcel P1 Pure Mathematics 1, and the topic is Equations and Inequalities. We have a combined handout of chapter number 2 and chapter number 3. Chapter number 2 is quadratics and chapter number 3 is equations and inequalities. So we have question number 52 of the handout, which is October 2019, paper 1, question number 3. Figure 2 shows a sketch of the curve C with equation y is equals to x square minus 5x plus 13. The point M is the minimum point of the curve C. Okay, the point M is the least point over here. The straight line L passes through the origin O and intersects C at the points M and N as shown. Find showing a working. The requirement of part A is to find the coordinates of M. Okay, then we have part B in which we have to tell the coordinates of N, and then we will move on to part C as well. So first thing first, what we have is we have an expanded form of the quadratic equation over here, which is y is equals to x square minus 5x plus 13. So what we can do, we can convert this into a completing square form, and then we would be able to tell the coordinates of M. M is basically the least turning point of the quadratic graph. So here we have a quadratic equation in an expanded form, which is y is equals to ax square plus bx plus c. So the formula for converting this expanded form into a completing square form is y is equals to a times x plus b upon 2a whole squared plus 4ac minus b square divided by 4a. All right. So what we are going to do, we are going to substitute the values of a, b, and c over here. As we can see that a is 1, b is minus 5, and c is equals to 13. So we just put this into the formula. So y is equals to 1 times x plus minus 5 divided by 2 times 1 whole squared plus 4 into 1 into 13 minus 5 whole squared divided by 4 times 1. All right. So what we get is y is equals to x minus 5 over 2 whole squared. And just evaluate this. The value of 4ac minus b square over 4a. So 4 times 1 times 13 minus 25 divided by 4. So this is positive 27 over 4. All right, we have the completing square form over here. So as we know the fact that when we have a completing square form, in this form that y is equals to a times x minus h whole squared plus k. So whatever is inside the bracket x minus h, this is equated with 0. Therefore, x is equals to h and y is equals to k. So therefore, we can say that h comma k is the turning point of the quadratic graph. All right, this is the basic concept behind this. And if the coefficient of x square is positive, meaning if a is positive, we can say that the turning point is minimum. And when the coefficient of x square, meaning a is less than 0, if the coefficient of x square is negative, so we are going to say that turning point is maximum. Okay, so this is the basic concept behind this. So what we have done is we have converted this general form of the quadratic equation into a completing square form. So therefore, I'm going to say that x minus 5 over 2 is equated with 0. So x is equals to 5 over 2 and y is equated with 27 over 4. So 5 over 2 comma 27 over 4 is the point M. Okay, either you can write it as a fraction or you can write the exact value in points form as well. So 5 over 2 is 2.5 and 27 over 4 is basically 6.75. So therefore we can say that the coordinates of M are 2.5 comma 6.75. All right. So this was the working for part A. The alternative way is to, differentiate the equation of the curve and get the dy over dx function and equate it with 0 in order to find the stationary point of the quadratic curve. You can do it in that way as well. Okay, we can use the alternative way over here as well. But right now, this handout is basically focused on chapter number 2 and 3 specifically. Okay, but I can give an alternative explanation over here as well. No worries with that. Equation of the curve is y is equals to x square minus 5x plus 13. So we are going to differentiate the equation of the curve. So dy over dx will be equals to 2x minus 5. So dy over dx is equated with 0, so that we get the x coordinate of the turning point, meaning x coordinate of the stationary point of the quadratic curve. So x is equals to 5 over 2. And when we get x is equals to 5 over 2, we substitute it back into the equation of the curve. So y is equals to 5 over 2 whole squared minus 5 times 5 over 2 plus 13. So just put this whole thing in your calculator. 2.5 square minus 5 times 2.5 and then plus 13. This is 27 over 4, which is 6.75. Therefore, we can say that the coordinates of M are 2.5, comma 6.75. So this was basically an alternative explanation. All right. So you can do it in either way. Now let's move on to part B. So part A is done. Let's move on to part B. Part B says that we need to find the coordinates of n. Okay, what we know the fact is that this line L is basically an upward sloping line which is passing through the origin. Okay, so when a line is passing through the origin, the y-intercept is equal to 0. Okay, I'll bring the picture of the question over here so I can have some clear space. Okay, so what we know the fact is that equation of the line is in the form y is equals to mx plus c, where m is basically the gradient and c is the y-intercept. Okay, this basic concept you have been studying since O level and IGCSE mathematics. All right, so as we can see that the line is passing through the origin, so c is basically equals to 0, meaning the line L is in the form y is equals to mx. And as we have established that the coordinates of m are 2.5, 6.75, and since the point m lies on the line L, so this means that we can find the value of the gradient of the line L over here. Agreed with this? Meaning I can substitute this point m into the equation of the line L. So this will be 6.75 is equals to m multiplied by 2.5. Okay, so therefore the gradient of the line is 6.75 divided by 2.5. How much this is? 6.75 divided by 2.5. This is supposed to be 2.7. Okay, so I can say that the equation of the line L is y is equals to 2.7x. Simple. So as we have found the equation of the line L, so what I can do, I can simultaneously solve it with the equation of the curve. The line L and the equation of the curve will be solved simultaneously so that we are able to get the two distinct points, and one of those two distinct points is already known to you through part A, which is the point M. We are interested in finding the coordinates of n over here. So I'm going to say that x square minus 5x plus 13 is equated with 2.7x. So x square minus 5x minus 2.7x plus 13 is equal to 0. So x square minus, we can say that minus 5 minus 2.7 is minus 7.7. So minus 7.7x plus 13, and this whole thing is equal to 0. So far we have achieved this thing, and now what we are going to do, we can use the quadratic formula over here as well. So x is equals to minus b plus minus under root of b square minus 4ac completely divided by 2 times a. Okay, when you are using a quadratic formula, so you need to show this step at least. Okay, so x is equal to 7.7 plus minus what? Inside the square root you have b square minus 4ac. So what is the value of b square minus 4ac? This is 7.29 and the square root of 7.29 is 2.7. Okay, and then completely divided by 2. So 7.7 plus 2.7 divided by 2. One value is x is equals to 5.2 and the other value is 7.7 minus 2.7 divided by 2, meaning x is equals to 5 over 2, which is 2.5, and x is equals to 2.5 is basically the x coordinate of point M, which we have already found in part A. So this means that the x coordinate of n is 5.2. And now what I'm going to do, I'm going to substitute it into the equation of the line or the equation of the curve to find the corresponding y coordinate over here. So simple way is to just use the equation of the line L, which is y is equals to 2.7x. So y is equals to 2.7 multiplied by 5.2. What is the value? 2.7 multiplied by 5.2. This is 14.04. So therefore we can say that the coordinates of n are 5.2 comma 14.04. This is supposed to be your answer to part B. All right, simple. So in part B, it was asked to find the coordinates of n. So first of all, I made an equation for the line L. As we know that L passes through the origin, so the y-intercept for the line L will be 0. So equation of the line L is in the form of y is equals to mx. And since we already found the coordinates of m in part A, so I substituted the coordinates into the equation of the line L so that I was able to find the gradient of the line L, which was 2.7. And then I equated the equation of the curve with the equation of the line L in order to find the points of intersection, which are m and n respectively. So x squared minus 5x plus 13 was equated with 2.7x. And then we were able to produce a quadratic equation, which I solved it using quadratic formula, and I got two distinct points. So x is equal to 2.5 is already the point which I have found in part A. Okay, this was point M. X is equal to 2.5, the x coordinate of point M. So for part B, we are interested in the other point. And then I substituted this x is equal to 5.2 in the equation of the line L, and I was able to find the coordinates of n. All right, so now let's move on to part C. Part C is basically based on inequalities, regions. Okay, so it says that figure 3 shows the curve C and the line L. The finite region R shown shaded in figure 3 is bounded by the curve, the line L, and the y-axis. So the requirement of part C is to use inequalities to define the region R. As we can see that the curve is broken over here for the region R, and the part of the line L is also broken over here. However, the y-axis is a smooth line, meaning x is equal to 0 is a smooth line. So a usual practice when we are solving inequalities, we are considering the inequalities when we have a broken graph. Okay, when we have a broken graph, we use strict inequalities. All right, so what do we mean by strict inequalities? Either it is less than or more than. Strictly speaking, less than, or you can say strictly speaking, more than. Either less than or greater than. Okay. And when we have a smooth graph, so a usual practice is to use non-strict inequalities. Okay. So what do we mean by this? Either less than or equals to or greater than or equals to. Okay. So this is basically a usual practice. All right. So what we can do over here is that as we know that this region R is basically below the curve. Either you can use the completing square form or you can use the expanded form. But since the expanded form is given to you in the question, so I would say that it's better to use the expanded form over here. All right. So since the region R is below the curve, so this means one inequality is that y is less than the curve, meaning the equation of the curve is x square minus 5x plus 13. So inequality is y is less than x square minus 5x plus 13. This is basically one of the inequalities over here. And as we can see that the region R is above the line and the equation of the line L is y is equals to 2.7x. So I'm going to say that y is greater than 2.7x. As we can see that the region R is above the line. And as far as the third inequality is concerned, so we can see that the region R is towards the right hand side of the y-axis, meaning x is greater than or equal to 0. However, we have an issue over here. What issue we have over here? As we can see that the region R is below the curve and above the line. We can see that the region R is below the curve and above the line, and x is greater than or equal to 0. Considering all of these statements which I just mentioned, we can also say that since the region R is below the curve and above the line, so region R should be this one as well. But over here, this part is not shaded, isn't it? If the inequality was like this, that it is below the curve, above the line, and x is greater than or equal to 0, so we are supposed to shade this region as well, right? But we are not shading this over here. In the question, this region is not shaded. Make sense or not? Even though this is below the curve and above the line, okay, and x is greater than or equal to 0, but it is not shaded. This means that the third inequality would have a special consideration over here, a special adjustment. And as we can see that this is restricted with the x coordinate of m. If I make a vertical line over here, x is equals to 2.5. So this region R is basically, you know, restricted up till the x coordinate of point M. Okay. And x coordinate of M is basically 2.5. However, we can also see that the region R, I mean the corner of the region R, or you can say the vertex of the region R is point M, and curve and the line are not included in the region because they have a broken graph. So x is equals to 2.5 should also be the same way. Okay, so this essentially means that the x coordinate of m, since it is 2.5, so the third inequality would be defined in this way, that x is greater than or equal to 0 but less than 2.5. This is the way to define the third inequality over here. Because if we do not restrict the inequality in this way, the third inequality, in the way which I have just mentioned, so this would mean that the region R is below the curve, above the line, and x is greater than or equal to 0. So this region should also be shaded. However, this is not the case. The region R is only restricted up till here. So we can say that the region R is restricted up till the x coordinate of point M. Okay, I can just mention this over here. Region R is restricted up till the x coordinate of M, and region R is below the curve and above the line. Below the curve and above the line, and is on the right hand side of the y-axis. I mean, this is a complete English description which you do not need to mention in the question. It is not a requirement, which is on the right hand side, right hand side of y-axis. I've just mentioned this description for your ease in order to make you understand. Okay, if you do not restrict the region R up till the x coordinate of M, so you would have to shade this region as well. However, this is not the case over here. So therefore, your answer is defined by three inequalities over here. First one is that y is less than x square minus 5x plus 13. The second one is y is greater than 2.7x. And the third one is that x is greater than or equal to 0, less than 2.5. Okay, for 2.5, I have considered a strict inequality over here. Okay, because it is restricted up till the x coordinate of M. And since I saw this thing that the curve is a broken curve, the line L is also a broken line. So the vertex of region R, which is point M, so it's best to not to include this x is equal to 2.5 into the region. All right. So in this way, we have answered part C. All right. So this was October 2019, question number 3, which is question number 52 of the handout. So now let's move on to another question. Question number 57 of the handout. This is January 2021, P1, question number 4. So the question says that the points P and Q as shown in figure 2, they have coordinates minus 2 comma 13 and 4 comma minus 5 respectively. This minus 2 comma 13 is P and 4 comma minus 5 is point Q. The straight line L passes through P and Q. Find an equation for L, and we need to write our answer in the form y is equals to mx plus c, where m and c are integers to be found. So first thing first, we have points P and Q respectively. So I can find the gradient of the line PQ, which will be the gradient of the line L. So y2 minus y1 divided by x2 minus x1, meaning change in y over change in x. So minus 5 minus 13 divided by 4 minus minus 2. Okay, so this is minus 18 divided by 6. So the gradient of the line is minus 3. Okay, so either you can substitute point P over here or point Q over here. So the equation of the line is in the form y minus y1 is equals to m multiplied by x minus x1, where x1 comma y1 is the point which is known. Okay, so I'm using point P. You can use point Q. So y minus 13 is equals to minus 3 is completely multiplied by x minus minus 2. So y minus 13 is equals to minus 3 completely multiplied by x plus 2, meaning y is equals to minus 3x minus 6 plus 13. So y is equals to minus 3x plus 7. This is the equation of the line L in the form y is equals to mx plus c, where m and c are integers to be found. This was the working for part A. So now in part B, it says that the quadratic curve C passes through point P and has a minimum point at Q. Find an equation for C. All right, so what we know the fact is that point Q is the least turning point of the quadratic graph. Okay, so if you know the turning point of the quadratic graph in the form of h comma k, so what you can do is you can make a completing square form. So completing square form is y is equals to a multiplied by x minus h whole squared plus k. And since we can see that, the turning point is minimum, so the coefficient of x square, meaning a, is positive. Okay, so whatever the value of a will come, obviously it will be a positive value because this is a U-shaped quadratic graph. Agreed? So since I know the turning point of the quadratic graph over here, which is point Q, so this is 4 comma minus 5. All right, so I can say that y is equals to a times x minus 4 whole square minus 5. But right now we don't know the value of a. So for that purpose, what we can do is we can use this point P over here in order to find the value of a, because point P is also lying on the quadratic curve. Okay, so point P is minus 2 comma 13. So what I'm going to do, I'm going to substitute this point minus 2 comma 13 over here. So 13 is equals to a times minus 2 minus 4 whole squared and then minus 5. So 13 is equals to a times minus 6 whole squared minus 5. So the value of a is 13 plus 5 divided by 36, meaning a is equals to half. And as we already know that the coefficient of x square is positive. Okay, so I can say that the equation of the curve is y is equals to half multiplied by x minus 4 whole squared minus 5. Okay, so you can give your answer in completing square form as well, because there is no specific requirement over here. If the expanded form was asked, if the expanded form was asked over here, so you would have expanded this completing square form. So this was the requirement of part B. All right. So now let's move on to part C. Before part C, we have some information that the region R shown shaded in figure 2, it is in the second quadrant. Okay, the second quadrant is over here. This one is a second quadrant. This is the thing. This one is the first quadrant. This one is the third one. And this one is the fourth one. So they have specified that the region R is in the second quadrant. All right. And it is bounded by the curve and the line L only, the curve C and the line L only. So use inequalities to define the region R. Okay, I'll bring the question on the next page, so we can have some space over here. All right. So what we know so far is that the equation of the line L is y is equals to minus 3x plus 7. Okay. And the equation of the curve is y is equals to half multiplied by x minus 4 whole squared minus 5. So these were the answers of part A and B respectively. So the region R, as we can see that, we can observe that the region R is below the curve and above the line. And the curve is also smooth, the line is also smooth. So I can simply make a statement that region R is below the curve and above the line. You don't need to make the statement in the exam when you are attempting this question in the exam. I'm just giving you some explanation for your ease, for your understanding. Okay, so the region R is below the curve and above the line. But if you say that the region R is below the curve and above the line, and there is no any other restriction over here, so the region which is below the curve and above the line, this region is also below the curve and above the line. But this is not included in the region R. This is not included in the region R because region R is specifically in the second quadrant only, as it is shaded in the question. If I say that the region R is just below the curve and above the line, so the region which is below the curve and above the line, this region is not included in the region R. So this means that we have to put a restriction over here. Agreed with this? Okay. So if I just say that, the region R is below the curve and above the line. So if I just mention this inequality that y is less than or equals to half times x minus 4 whole square minus 5. And if I say that since the region R is above the line, so y is greater than or equals to minus 3x plus 7. These two inequalities are correct, but it is incomplete. We have a third inequality in the process as well. Okay, we have a third inequality in the process as well. So as we can see that the region R is restricted up till the x coordinate of point P. What is the x coordinate of point P? This is minus 2. So we have a vertical line which is x is equals to -2 over here. Okay, so we can say that the third inequality which is in the process is x is less than or equals to -2. All right. Either you can use strict inequalities in all of the three cases. Either you can use strict inequalities in all of these three inequalities, or you can use the non-strict inequalities which I have used over here. But the use of the inequality notation should be consistent. Either all of them are strict in this case, or all of them are non-strict in this case. Okay, because the curve is smooth as well, the line is smooth as well, and obviously the vertex of the region R, which is x coordinate of P. So if I make a line, a vertical line, x is equals to -2, that would be smooth as well. But even though in the cases of a smooth graph, you can still use the strict inequalities. But the use of the inequalities should be consistent throughout. Either all of them are strict or all of them are non-strict. Okay, so in this way, I have defined this region R. So region R is basically restricted up till the x coordinate of point P. I can say that the region R is below the curve and above the line, and restricted up till the x coordinate of P. Okay. Alternatively, you can restrict this up till the x coordinate of Q as well. Okay, because when we are specifically saying that the region R is below the curve and above the line, so obviously this region which is in between is very obviously not included, because this region in between is basically above the curve and below the line. So when I'm saying the region R is below the curve and above the line, so obviously the region in between is already eliminated, not considered. So you can restrict the region R through this inequality as well, that it is restricted up to the x coordinate of Q. You can use this x coordinate of Q as well. Okay. But however, whatever feels simpler, effective, efficient, quick, the best way is to do that way. Okay, so the best way is to use the x coordinate of P over here. So in this way, we have defined the region R. All right. So this was the question number 57 of the handout, which is January 2021, question number 4. All right. Then we have question number 63 of the handout, which is January 2022 P1, question number 4. So the question says that figure 1 shows a line L with equation x plus y is equals to 6 and a curve C with equation y is equals to 6x minus 2x squared plus 1. The line L intersects the curve C at the points P and Q as shown in figure 1. Find using algebra the coordinates of P and the coordinates of Q. As simple as that, we just need to equate the equation of the line with the equation of the curve. So if I rearrange the equation of the line, so this is y is equals to minus x plus 6, and I'm going to equate it with the equation of the curve. So 6x minus 2x squared plus 1 is equals to minus x plus 6. Okay, so far we have achieved this thing. So I'm going to collect all of the terms on one side. So 2x squared minus 6x minus x 2x squared minus 6x minus x plus 6 minus 1, and this whole thing is equals to 0. So 2x squared minus 7x plus 5 is equals to 0. Okay, so if you want to do factorization, so 2 times 5 is 10. And after addition, we need to get minus 7 in between. So 2x squared minus 2x minus 5x plus 5 is equal to 0. So taking 2x as common multiplied by x minus 1, taking minus 5 is common, multiplied by x minus 1, and this whole thing is equal to 0. So therefore, x minus 1 multiplied by 2x minus 5 is equal to 0. This is the fully factorized form over here. So when x minus 1 is equated with 0, so x is equals to 1. And when 2x minus 5 is equated with 0, so x is equals to 5 over 2. So what I can do, I can simply substitute it into the equation of the line L, which is y is equals to minus x plus 6, meaning y is equals to 6 minus x. So y is equals to 6 minus 1, so y is equals to 5, and y is equals to 6 minus 5 over 2, meaning if we subtract 2.5 from 6, we get 3.5. So y is equals to 7 over 2. Okay, so therefore you can say that the coordinates of P, as we can see that, x coordinate of P is smaller than x coordinate of Q. Okay, you need to make sure of these things. Okay, so therefore we can say that the coordinates of P are 1 comma 5 and coordinates of Q are 5 over 2 comma 7 over 2, or you can say 2.5 comma 3.5, same thing. Okay, so this was the solution of part A. After this we have part B. It says that the region R shown shaded in figure 1 is bounded by the curve C, the line L, and the x-axis. Use inequalities to define region R. Okay, so it is bounded by the curve C, the line L, and the x-axis. So as we can see that the region R is below the line and it is above the curve and it is above the x-axis, above the x-axis as well. Okay, so step by step, we are going to define the inequalities. Since the region R is below the line, okay, and the line L is smooth, so I'm going to use this inequality over here that x plus y is less than or equals to 6. Okay, as the equation of the line is given to you, x plus y is equals to 6. So I have used the equation in the same form to define the inequality. And since the region R is above the curve, so I'm going to say that y is greater than or equals to 6x minus 2x square plus 1. Okay, first we have two inequalities. And since the region R is above the x-axis, okay, it is above the x-axis, this means y is greater than or equal to 0. So first we have these three inequalities. But however, if you are saying that the region R is below the line, above the curve, and above the x-axis, so this region which is not shaded, this region which I am shading myself over here, this region is also above the curve, below the line L, and above the x-axis, isn't it? But this region is not included in the required region in the question. Make sense? Okay. If you are just saying that the region R is the region which is below the line, above the curve, and above the x-axis, so this region which I am shading myself, this is not included in the region R. So this means that there is a fourth inequality in process. There is a fourth inequality which we have not yet considered over here. All right. So what we are going to say that as we need the region below the line, above the curve, and above the x-axis, so we have a restriction from the x-coordinate of point Q. Agreed? We have a restriction from the x-coordinate of point Q. And since all of the graphs are smooth, so I have made a smooth vertical line over here for the consistent use of the inequality. Okay, so the point Q is having the x coordinate 5 over 2, or you can say 2.5. This is the line x is equals to 5 over 2. Okay, so I'm going to say that my fourth inequality is that x is greater than or equals to 5 over 2, or you can say x is greater than or equals to 2.5. Same thing. Okay. However, if you consider this x-intercept of the line L, which will be x is equals to 6, as the equation of the line L is x plus y is equals to 6. All right. So if you say that, is it important? Is it important to consider the x coordinate of this point? Is it important to consider the x-intercept of the line L over here? The answer is no. Why? Because when we are saying that x is greater than or equals to 5 over 2, and we are saying that the region R is below the line, above the curve, and above the x-axis, so automatically we are not considering this region which is under the x-axis, because the region R is supposed to be above the x-axis, right? First thing first. And obviously this region is above the line, so we also are not considering any region which is above the line. So this region is obviously eliminated over here. However, since we are considering the region above the curve, below the line, and above the x-axis, so obviously we are not considering this region as well, because this one is, you know, under the x-axis. All right. So obviously this x is equals to 6 is not important to be considered. However, if you consider this x is equals to 6, I mean, if you say that x is greater than or equals to 5 over 2 less than or equals to 6, that is also fine. But it is not a compulsion to use this x coordinate of the uh, x-intercept of the line L. Okay. Solely due to this reason, because we are considering the region below the line and above the curve, but only above the x-axis. So obviously this region which is under the x-axis, under the line and above the curve, this will not be considered over here, all of this thing. So when you say x is greater than or equals to 5 over 2, so this is enough. And in order to make a consistent use of the inequalities, I have used the inequality in the same way. X is greater than or equals to 5 over 2. So this is your best answer, and this is your final answer, and you will get full marks over here. And one more thing which I like to discuss over here is that one last thing, that when we say that the region R is above the x-axis, we are saying that y is greater than or equal to 0. But if we see the y coordinate of point Q, if we make a horizontal line over here, and the y coordinate of Q is 3.5, meaning y is equal to 7 over 2. So y is equal to 7 over 2. Here we have a horizontal line. So we can also say that y is greater than or equal to 0, less than or equal to 7 over 2. In the same way, as I was trying to tell, that we can say that x is greater than or equals to 5 over 2, less than or equals to 6. However, the two inequalities in this form are not compulsory to be mentioned. If you write your answer in this way, that is also perfectly fine. Okay, but it is not compulsory to mention this over here. So a complete alternative way to write all of the inequalities, that the region R is below the line L, region R is above the curve, okay, and the region R is above the x-axis. So this above the x-axis inequality can be mentioned in this way, that y is greater than or equal to 0, less than or equal to 7 over 2, and x is greater than or equals to 5 over 2, less than or equals to 6. This is a complete alternative way to write your answer. But this is not compulsory to use, because when we are saying that y is greater than or equals to 0, the region R is above the x-axis, Okay, so obviously we are considering this thing at the same time when that x is greater than or equals to 5 over 2. So obviously the region R, which is shaded in the question, is already defined. Okay, so this is not compulsory to use over here. Obviously, when we are saying that x is more than or equals to 5 over 2, so the restriction of point Q is obviously there. Okay, so these two are not compulsory to use. However, if anyone uses it, that's perfectly fine. You will get full marks. But this is not compulsory to use. So either you can write your answer in this way, or you can write your complete answer in this way. Right? So this is how you solve this question. Okay. But the way in which I have already, explained things, that is already enough. So these are just some extra explanations over here. So the thing which is brief, concise, effective, and quick and helps you achieve full marks, that is already more than enough. Okay, so this was just an alternative explanation. So I'm erasing it over here. So you write your answer in this form, you will get your full marks. All right, so this was the explanation of question 63, which is January 2022, question number 4. So in this video, I have discussed 3 past paper questions. This one was January 2022, question number 4. The earlier one was January 21, question number 4. And the earlier one was October 2019, question number 3. So inshallah, I'll be making more videos. I'm going to make them public on my YouTube channel, and stay tuned to my channel. And those who have any queries, particular queries regarding any questions, so they can communicate me through WhatsApp. I'll be more than happy to help. Thank you for watching. See you in my next video. Allah Hafiz.